Hi, we are engineering brothers, and once again we have come out with our another interesting problem over here. And quite naturally, this is our last problem for our torque voltage analogy additional problem for over here. And you can see that we have got the more complex problem in our rotational system over here. So if you do apply the torque at this extreme end point over here, we can see that the rotating considerations for our moment of inertia of J1, J2 and rotational spring elements of our K1, and of course the K2 and J3, and of course the rotational friction coefficient, that is B3 and B4, J4, all are getting disturbed by this applied torque over here. So I just once again do like to say that if you do apply the torque at this point, we have considered that all the elements of a rotating block for our given system of J1 Q1. So what is the value, or what is the exact consideration for a J1? J1 is quite naturally the moment of inertia for our mechanical rotational system, and K is quite naturally a rotational stiffness for our given system, and of course the J2, K2, J3, and what is the B3? The B3 is the frictional element or frictional coefficient uh, due to the considered mechanical rotational system over here, and B4 is quite naturally the same over here. So if you do apply the torque at this point, all the bodies are getting disturbed by that applied torque, and all the portions of our considerations are getting disturbed by that. Now quite naturally I'm just going to follow up the same procedure over here. So first I'm just going to draw the first nodal diagram over here. So quite naturally, to draw the nodal diagram, I have followed the same procedure just like our previous problems over here. So if you do consider the quite essential angular displacement factor over here, so I am just going to note down our angular displacement considerations over here. So first one is our theta 1t, and the second one is our theta 2t. So this one is our theta 2t. Third one is quite naturally our theta 3t, this one, and the fourth one is our theta 4t for this one. So this is not been mentioned in our diagram over here, so this one should be our theta 4t. Okay, now we are going to include our next considered part over here, which is our theta 4t. Now what are the connecting elements with our much needed angular displacement considerations over here? So let us first find out that one and do connect in our given nodal diagram over here. So you can see that at this point we have got the G1. So G1 is directly associated with our theta 1t. So I am just going to include our G1 over here. So this is our G1, and quite naturally in between our theta 1 and theta 2t we have got the K1. So in between our theta 1 theta 2t we should include the K1 over here. So this is our K1 that has been included over here, and theta 2t is directly associated with our J2. So let us do connect over here with our theta 2 theta 2t. I'm just going to connect the J2 over here. So this is our J2 that has been connected over here, and with our theta 2t, in between our theta 2t and theta 3t we have got the K2. So this is our K2. So this is our K2 that has been connected over here, and with our theta 3t we are going to connect the J3 over here. So this is our J3 that has been connected over here. With our theta 3t I'm just going to connect the J3. So this is our J3, and with this considered part we have realized that the friction element of a B3 that is been directly associated with a theta 3 over here. So you can see according to our diagram. So we are just going to include the dashpot element which has got the value of B3, and we are going to connect that with our angular displacement factor of theta 33 over here. So this is our B3 that is been connected over here. And for that last part, for our theta 40, we are going to connect our J4 over here. So this is our most considered part for our J4. So J4 has been connected over here. So J4 has been connected, and once again the B4 has been connected over here. So this is our B4 that has been also been connected over here. Okay, and in between our theta 33 and theta 43, the spin element of K3 that has been included over here. So this is our K3 that has been included over here. So this is quite naturally our theta 43, and this is our block. And at this extreme left hand side, we are going to include the torque element over here. So let us do include the torque element at this extreme left hand side over here. So this is our applied torque that is being connected over here. So this is our complete nodal diagram over here. How to form the nodal diagram, I am just going to repeat over here. So first we do require to find out at which point we are going to apply the applied torque. So for that consideration, you can see that we have applied the torque at the extreme left hand side for our mechanical rotational system over here. Now if you do apply the torque at this point, all the bodies or the whole structure of our rotational system are getting disturbed by that applied torque. Now if you do apply that torque at this point, the rest of the angular displacement part has been considered over here. So first we are going to consider the first angular displacements over here. So this one is been associated as, this one is our theta 1t, this one is our theta 2t, and the next one is our theta 3t, and quite naturally the next one is our theta 4t. And we have included first, or we have identified our angular displacement factors over here. So first one is our theta 1t, the second one is our theta 2t, the third one is quite naturally a theta 3t, and the fourth one is our theta 4t. And we have included these angular displacement factors over here, and we have included those point as our consideration. And at our next part, what are the elements that are connected in this nodal diagram, we do require to first identify that one over here. So I'm just going to say that with our theta 1 3, the J1 block is directly connected over here, and in between our theta 1 3, theta 2 3, the spring element of K1 is been present over here. So in between our theta 1 3, theta 2 3, we are going to having the K1 element over here. So I have included the K1 over here, and with our theta 1 3, the J1 is been included over here. And at this theta 2t, the J2 block is connected over here. So I have included the J2, and in between our theta 2t and theta 3t, the K2 spring element that is been present over here. So in between our theta 2t and theta 3t, the K2 element is been present over here. So let us move on towards our theta 3t point over here. So with our theta 3 point, we are having that the J3 has been directly associated over here. So I have included that J3, and the rotational spring coefficient of B3 that has been present in between this surface and this rotating body of J3 over here. So I have included that or I have connected that B3 element with our theta 3 over here. And if you do move on towards our right hand side for our circuit, we do have the J4 is been directly connected with our theta 43 over here. So the theta 43 has been connected over here, and the frictional element of B4 that has been associated over here, that I have included over here. And quite naturally, in between our theta 33 and theta 43, the spring element of K3 that is been present in between these two elements over here. Now in our next step, we are going to apply the D'Alembert principle at each and individual angular displacement points over there. So I am just going to write down, or we are just going to make the numbering considerations over here. So this is our number 1 node over here, this is our number 2, this is our say this is our number 3, and this is our number 4. And if you do separately apply the D'Alembert principle at this point 1, 2, 3, 4, we are having 4 differential equation for our mechanical rotational system over there, and that will be the next thing for our upcoming part for a video. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel, and just wait for my next part. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.